Hi everybody, welcome to the May.NET user group here in Melbourne. So tonight we've got a good show in store for you, a lot of demos, so let's get cracking. But first, I have a QR code here that if you scan that, you can install our rewards app and you can get some points, win some swag. It's a good bit of fun, and you can compete with your friends. So you can see who climbs up the leaderboard. Every time you come to an event or talk to one of us, you can get our personal code and get some more points. And if you get to the top of the leaderboard, there might be a surprise in store for you. So I'll give you a sec to grab that. A few people's already got it. Cool. Okay, so tonight I'm going to talk to you about unleashing the power of microservices with Dapr and Azure Container Apps. Now, my name is William. I'm a solution architect here at SSW. You can find me on Twitter, just for a bit of fun chat. I have a blog called azuregems.io. So now and then I might put something up there, but I think after this, I've got a big write-up to do about ACA and Dapr. If you want to engage me a little bit more formally, you can find me on LinkedIn as well. Now, I started coding quite a long time ago. I was about 5 years old, I think. And my first app was written with BASIC on a Spectrum Video 328. There you go. Someone knows what that is. So then, a long time later, I started a real job with doing 3D graphics programming, real-time 3D stuff with virtual reality, Oculus Rift, that kind of stuff. More of an industrial setting to make sure people train themselves to work safely in dangerous situations, to not hurt themselves or to kill anyone. It's good fun, hardcore, but then .NET came around and a Skits version 1. I thought it was kind of weird, crazy thing coming out of Microsoft. V2 landed, I was hooked. I have been on it pretty much every day since, built most of my career on .NET. So good to say I'm quite happy. And we'll see a lot of .NET tonight as well. Then same with Azure. I've been on that since 2014, and most days I could play with all sort of the things you see on the screen there and more. So this is definitely my happy place. So we know microservices are painful, right? We've heard the news recently, what happens. It can be expensive and, all sorts of problems. Now, these are just some of the things you have to consider with dealing with microservices before you even get to write any of your business logic or your application code, right? You have to make sure they're resilient. Look at trying not to make them too complex and how services can talk to each other or discover and so forth. The costs, everything. You need to consider all of this. It's easy for a monolith to do all this. Well, not that easy. When you then go and do it with microservices, each service that you add just compounds the effect of all of these things. It becomes increasingly hard to deal with microservices. So they are painful. All right. Now, tonight, I'm going to try and focus on just 4 of these things, not all of those, but Dapr and ACA pretty much helps us solve something in each of these categories, which is great. Okay, so I'm going to discuss with you quickly what are Azure Container Apps, what is Dapr. We'll show you how we can do some development with it, how you put the two together, ACA and Dapr, and we've got some cool live demos. So Azure Container Apps, it's a new flexible container app environment, specifically for running containerized applications. It's different to app services, more tuned towards running your code directly on the app service rather than in a container. The app services don't scale anywhere near in the same way that container apps can scale. And the reason is ACA is built on top of Kubernetes, but you don't have to use Kubernetes. You don't get involved with it. And this is a nice thing about ACA. All the hard work has been done for you already. We get serverless scaling from 0 to n. So, most people would say serverless means it has to go down to 0, and I agree. Now, this means because it's containers, it's any sort of thing that you can run in a Linux container, you can run in ACA, and it can be serverless and automatically scale up to whatever level you want with a whole lot of cool metrics using Kida, which is the Kubernetes event-driven autoscaler. But and it's quite straightforward to tune that, and it can look at a huge variety of things to help you scale your application, at the right time, scale it out just far enough, not too wide, not too high, all those kind of cool things. So we've got Envoy for some really cool advanced routing that's part of ACA, and we're going to use some of that tonight, as well as the best thing is it comes with managed Dapr. So it's the easiest way to run Dapr and the sidecars that you need in an environment where they basically take care of everything. You then just focus on the applications that you want to write, not the infrastructure or any of the stuff underneath. That's all done. Which I just said, and all our apps, they get to run in a VNet boundary. They're all there in one environment. They all get to talk to each other, and we can choose whether we want some endpoints to be public or to be secure or private. It's straightforward. A really nice feature of ACA as well is that we get to work with revisions. That means we can, and there's different modes. So there's single mode and multiple mode. The single mode still gives us zero downtime deployments. So it'll just temporarily spin up a second container when we deploy, and when it's ready, it'll swap the containers around. So the new one becomes the active one, and the old one just sort of goes away. In multi-mode, you can actually go and do all this cool sort of traffic splitting or blue-green and other types of deployments. So a lot of options there. They're quite flexible. And that's not it. There's actually a whole lot more stuff, but for me, these are the top bunch of features. So I just want to quickly go and show you in the Azure portal what the container apps look like. Okay, so I'll find my mouse. That's weird. All right. So here I have a resource group that's already got a bunch of stuff in there for tonight's demos. So I've got a service bus, I've got a log analytics, bit of a tongue twister, key vault, the container registry where my apps go into. And then most importantly, here's the container app environment. And then all my little apps, well, microservices, they all live within that environment. And then here's a few other little bits as well. Okay. So in the CA environment, you see some basic details, and it's got static IP and so forth. And, we can go and see what Dapr components we've added, and I'll go through what they mean later, just some standard DNS stuff, and we can see the apps that are currently running in that environment, and we can navigate to them, and just some logging stuff. Cool. So let's pick some app here. I'm going to pick the first one. It's the Cart API. And this is running on these are all Linux applications running on a container. It has got a URL. You'll notice this one says internal. It's a bit hard for me to get there. There you go. It's an internal one. So it's a private URL. If I hit that, I can't actually get to it. It's not there. Or it's as if it's not there. All right? Doesn't work. And then, we can monitor them. There's some telemetry, the usual stuff, authentication. So you can actually use the easy auth stuff in Azure to authenticate your endpoints or secure them. You can manage secrets, the ingress. So here's where we can choose what sort of access our apps have to each other and to the internet, and what port and protocol we want to use, etc. Pretty cool. Again, there's some more Dapr stuff, but most importantly here is the revisions. Let me see. I didn't edit anything. Thank you. Okay, sure. Thinks I did. So currently there's only one revision running. That's fine. It's as expected. I'll show you later when we deploy how you get another one there. When we get to the containers, this is where we can see which container registry is running from, which image I'm using. And of course, we like using long, crazy numbers for things. But I can also see the sort of resources that I've allocated to this. And I can run half a CPU. So literally, I always see someone, or imagine someone having 2 pieces of CPUs in their hands. I don't know why. Environment variables, all the stuff that you want to add in, health probes for readiness checks, etc. And then with the scaling, we can't talk microservices without scaling. So I've just got a basic setup right now. But what we could do is, if we actually wanted to, I could edit this and say, hang on, that's in the wrong spot. Go here, the next blade. So I can actually say, go down to 0. I want it to be completely serverless and deal with cold starts and so forth. Or, well, actually, they've increased this. This used to be only 30. How am I going to get 300 instances of a shopping cart running? That is awesome. Okay, I love it. Or I also have the minimum set of servers running for my app. So that's awesome. They must have just changed this very, very recently. Okay, cool. Get ready to spend a lot of money. Okay, and then we can add those scaling rules. And this is where, we can look at the stuff from Kita. You have to look up the schemas for things and map them into here. But yeah, we'll get to some of that later. Okay. Yeah, I don't want to save any of this. Thank you. Go back here. All right. And so we'll probably spend a bit of time in here. And logs, it's quite useful to just go into the log stream and you can see if the app is running, and it's the usual console output. All right. Nice. So let's go back. So now and you've seen, actually, I'll show you a live one. Just, it's not smoke and mirrors, okay? So here is my gateway API that is open to the public. So it's got a public ingress. Of course, nothing on the root there, but I have one of the usual Swagger docs open, and here's all the endpoints that it exposes from my microservices. Okay, so it is working. You can see it's got this crazy URL there, and while you're sitting there, how about I open up the URL to this? You should be able to grab this, and you can go and try to spam my awesome little Dapr shop. All right. Oh, everyone's giving it a go. Cool. I'm looking forward to this. Right. Okay, everybody good? Can access that, yeah? Cool. All right, well, how about I'll give you the first step. Go down to users and register yourself. I know doing it on a phone might be a little bit annoying, but you'll have a bit of time, right? So let's zoom that in. So yeah, give yourself a username, a real email if you want to actually receive something later, display name, keep it clean, and then the profile URL, that doesn't matter at the moment. You can do anything there. Okay, so there is an app. It's working. You can use it, and we'll see what's in there a bit later. All right. Now we know what container apps are. And the next thing is, what is Dapr? Has anyone actually used Dapr before? I know one guy's interested in Dapr already. All right. So it's an open source project. It's part of the, originally started in Microsoft. Now it's part of the Cloud Native Computing Foundation. It is an event-driven portable runtime for building microservices. It's not the ORM that a lot of people think of Dapr. Completely different. Now, it says microservices, but you can 100% use this for any type of service, okay? The building blocks and the things that comes with it, they can work in a lot of scenarios. So don't worry that it says just microservices, okay? Now, Dapr is platform agnostic. It can run anywhere on your local machine. You can run it in a VM, you can run it in Kubernetes, in ACA that we just saw, and you can run it in any of the clouds, all right? So it run anywhere. That's good. It's also multilingual. There's an SDK for all our favorite languages. Yeah, .NET, C++. You can even use PHP. So I don't know how someone decided they're going to put Dapr onto PHP and supercharge these WordPress sites. But hey, you can do it. So we'll see. And when we're talking about Dapr, we hear a lot of people saying building blocks. What are they? There's sort of like abstractions, sort of APIs there that make our life a lot easier. They already solve problems for us and given us an easy way to deal with them. Okay. You also hear a lot of about sidecar architecture, and it's a process that sort of runs next to your application. Sometimes you can run it in your application, but in Dapr's build, it's a separate application that works with your application. So just like the little sidecar scooter there. And we'll see more of this as well. Building blocks address common challenges with codified best practices. So they've taken some of these issues that we commonly deal with, a lot of those ones from the list at the start, and they've implemented the best practice to solve them. So they're all callable APIs, and they can be called via HTTP or gRPC. And gRPC is pretty cool. It's very compact and fast format, so you can squeeze a lot of performance out of your systems. So when you think of building blocks, one of them could be service-to-service communication, right? So you got a lot of little microservices out there. They're going to have to talk to each other at some point. So definitely over HTTP or gRPC, and that's hard. Having to tell each service where the other service is, what their address is, and how to get there. That's hard, and it's annoying, right? Dapr has a cool way of helping with that. We'll see how that works. State management. So if you think about key value pairs, we have a lot of state we want to store in our applications, and we can even then make stateful microservices. We can have state that tracks across multiple services, not just in one. All right. And because it's the sort of distributed state, it doesn't matter if our microservices scale out or not. That state's still available, it still works. PubSub. So that's another way that we can use, or a technique we can use to decouple our services. Instead of doing service to service, we can do PubSub. We can send a message, we can put it on a queue or in a topic, and whoever's interested, they can then pick that off and do something with it. So that's a bit more event-driven type architectures that we deal with. And you think of Azure Service Bus, Kafka, RabbitMQ, MQTT. There's quite a lot of things out there that we can use for messaging. And bindings. This is something quite special. It lets us abstract our services even further. So we can actually have a binding into something like SendGrid or SignalR, or you can write your own one, and it can run in a sidecar and not in my application. My application is going to be very much just business logic or application logic, nothing to do with infrastructure or even configuration. And we'll see what that looks like. It's pretty cool. And actually, there's a lot more building blocks like this. There's not just the service to service or state management, PubSub, we've got actors, observability, a way to manage with secrets, and share secrets around, the way you configure Dapr and other applications, distributed locks. That's kind of cool. Because we have distributed state or systems, sometimes we need to have a lock there to guard against something from happening. It's quite useful. And then workflows, which if you've done, say, Azure Durable Functions, this is very much the same thing. The API is almost exactly the same too. So we can then pull this straight into a ASP.NET application. It's really awesome. Cool. So in a different view, we can see here we've got our application on the one side, have a little Dapr Sidecar, and it's a Dapr Sidecar that then connects to these building blocks for us. And you look at, say, the state store, with a whole lot of logos in there. It's not all of them. There's actually a lot more. But we can actually start with Cosmos DB and eventually end up in Redis. If we decide to swap our infrastructure, we can do that. But we don't have to change any of the code in our application. All right, I'll show you that for real, how we actually do that. Same, for instance, with the PubSub brokers. We can start with Azure Service Bus, but later on we can use RabbitMQ or Kafka, whatever. There's a lot of choice. All right. So now, what is the sidecar? What does it actually do? Well, like I said, it's the building blocks are callable APIs. So in this instance, I've got an application on the left running on localhost, port 80 or whatever, and it needs to talk to the sidecar. So by default, it's going to be port 3500, and we call the invoke. So that's all the service-to-service invocation. It can talk to one of the other applications in the sort of Dapr network, and the two sidecars would talk to each other securely. They know who's who with the sort of application ID, which we'll see in a minute, and it will make sure it finds the right service. It knows where to find application A and application B, and the communication is routed from app A to its sidecar, to the sidecar of app B into application B. All right. Same with state. If we need to retrieve state from a storage account or Redis, we can do that with just a HTTP call. Quite nice. Now, these components, we have to describe them. Unfortunately, we have to use YAML. But that's okay because they're not that complicated either. They don't actually get that big, which is nice. All right. So on the one side, I have a state store that uses Redis. And all we have to do is say that it is a, see, my little pointer works. Nope. All right. All we have to do is to say that it's a state of type Redis. We give it a host name and a password, and that's it. We've got a few other small optional things we can add later, but we can then swap that later. If we decide, hey, we don't want to use Redis for our state store, we want to use Cosmos DB, we can do that as well. All we have to do is change the type under the spec, give it a URL, a key, and a couple other things to say, which database and which collection to use. And that's all we have to do. Our application doesn't care. It just, I'll show in a sec what the application does is just call an interface and Dapr takes care of the rest. Yeah. So I'm going to jump over to Visual Studio. Okay. Can everybody see that? Big enough? Okay. So here I have a bunch of microservices that make up my shop API. One of them is a shopping cart API, and a whole bunch of other ones as well. And then I've got a set of Dapr components that I use in my application. So for instance, here I have a state store that is using it's a Cosmos DB state store. I'm using the local emulator currently, and providing it the master key as a secret, giving it a name for which database to use in my Cosmos DB, and also then the collection inside of that database for where to store my state. I have another one called secrets. This is where I keep some local secrets that I reference from a local file called secrets.json, and that's the one that is being referenced here for Cosmos DB. You can see that name there, local secrets. That name is the same as this name here. Okay, cool. So I don't have to commit any secrets. Quite nice. And then finally, I've got a pub sub of Redis that I use for sending messages and events. Excuse me. Okay. So then, here's the name for it, called Dapr shop-pub sub. Now in my microservice applications, start with a web application builder. Very first, I add the Dapr client. Very important. Need that. That's going to help us do all the magic. And along with that, to be able to add that client, I have to first add a couple of NuGet packages. So first off, I add the Dapr client NuGet package, as well as the Dapr.ASP.NET Core package. And together they let us add in some really cool stuff to our application. Now, I just made things a little bit more complicated by adding in the application insights package. But you can see there's nothing else being referenced here other than my own projects for some contracts and some cool extensions that I wrote for Dapr. Now, off we go. I go add in a few extra things. So one of them is a custom service that I wrote for providing my shopping cart functionality. I'm wiring in some application insight stuff here, enabling the OpenAPI spec to be generated, or Swagger. If you want to use Swagger, it's also a possibility there. Very importantly, I then map the subscribe handle, and this is the part of Dapr that will enable our applications to listen or subscribe to a queue or a topic, and then whenever anything lands on there, it will then send it to our application or this particular shopping cart API for any of the payloads or any of the messages that we're interested in. Also serving some static files, specifically just in this case for the Swagger specification and enabling the Swagger UI, and finally adding some minimal endpoints to define the endpoints that are available to interact with this microservice. Okay, so just a basic get endpoint, give it a username, and my cart service that I injected earlier, or that I set up earlier to be injected. And so that, for instance, this one just returns the shopping cart for a particular user. A few other things here. They're all very straightforward, sort of a post for adding items to a particular user's cart. And then finally to submit an order. Cool. So all very basic stuff. Now, let's dig a little bit deeper. So I want to look at what Dapr does for us when I dig into get cart. Now here we see I have inside my cart service, I've got a get cart method. I'm using this thing called the Dapr client to get some state using the get state async API and to return it for my cart type. Now, what I give it is firstly the name of the state store that I want to use. In this case, I've called it way up here, the Dapr, but I've called it the Dapr shop state store. If we look in my state store YAML component, here's the name, and then of course the spec, however it's described. Cool. Now that's all my application cares about, is the name of this component that I use. Nothing else. Doesn't care if it's Redis, Cosmos, doesn't care. All I work with is this beautiful basic abstraction of getting state from whatever name it is, and the key of that state value that I'm after. So we're talking with key value pairs here when we're talking about state. So very simple direct fetch kind of stuff. Now, in this case, if I get a cart back and it's null, I create a new one, give it the name for the user who we're interested in, so everyone gets a cart. You get a cart, you get a cart, you get a cart. Awesome. And then I return that back to the caller. Okay. Now, if I go back to my endpoint, I have then the next one here, which is adding an item to a shopping cart. So it might be a little bit more interesting to see what happens here. Now, before I get to add any products to this person's cart, I actually have to talk to the products API to see, hey, is this product that we're asking for a valid product? And so we're using this little shortcut provided by the Dapr client to create a HTTP client, a standard HTTP client, but sort of wired up with a few bits that it knows using this API, the app ID products API that we assign to all of our apps. Okay, it knows how to discover this. It knows what the real localhost port 7000 whatever number is, or once it's published into the real world, whatever the real host name is to get to that that client or that service. All right, so all we have to provide is the app ID, super basic, and then from there it's just a standard HTTP client we're all familiar with, and then we can use the bits that we're familiar with. In this case, I'm just standard call to the products/get endpoint, give it a query string of the product ID, and then if it all goes well, I get back a valid product. If it's not a valid product or it doesn't exist, then I'm going to throw an exception. Now, I'm doing the same thing with the users API, making sure that this user who I'm trying to add a product for is a valid user, that they exist in our system, they've registered. And if not, then of course, just throw a nice exception. And then I can go on and deal with the cart. So make sure I get a cart for this user, find if the item is there already or not. If it is already in there, then I update the quantity. So I'm using records here, so you might notice a little with keyword, keep things nice and immutable. So I am creating a new version of this item with an updated quantity that I've passed in, and then take out the old one and add in the new one to the cart. Cool. All right, so then what I'm doing is, if it doesn't exist, I just create a brand new item, just chuck it in to the cart because it doesn't already exist. I don't have to update it, just add a new entry. Now my cart got new stuff in it or updated something into the cart. I can now go and just call save state. So again, I give it the store name, I give it a key, which is the username. All right. So store this particular cart for this user in that store. Very simple. That's all we need to do. The interface is quite straightforward. Now, once I've done that, I can do something a bit more interesting. I can even go ahead and publish an event stating the fact that this particular user added this product to their cart, and whoever wants to know about that, they can subscribe to this topic that we're publishing to and receive this method, can receive this event with these details and then act upon it. So again, we just use the Dapr client, publish event async method. We tell it which pub sub to use in this case. The same like with the state store. I can say which pub sub component to use. on whichever particular topic, and then the payload or the event that I want to publish. Okay, awesome. Okay, so now you can see, very basic usage of the Dapr client. The interface itself is actually quite straightforward. So if we just go here, Dapr.discover it a bit, there's some basic bulk operations, some invocation methods, some deletes, get bulk state, get configuration, get secrets, get state, which we saw, get workflows, which was pretty cool. So stateful workflows, and we can invoke a few bindings or specific methods on other APIs, and publishing events, so forth, saving state, and a couple other things. Not too much in there. It's not a massive interface. It's quite straightforward. Everything does pretty much what it says on the box. So we just deal with those abstract concepts rather than knowing it's exactly Redis or RabbitMQ or Cosmos DB, whatever it is. We don't care about those details anymore. It's just, I want to save some state, I want to get some state, publish a message, and saying that, once we've published a message, how do we listen to it? Well, okay. So here we can see I've published another one, even when someone's cleared their card. But let's say I've got this other API. It's called my notifications API, and I can go look at its endpoints. So again, I've got the same sort of setup here, just with the names of the components that I'm trying to listen to. So here's one of the pub sub names. Here's also the card topic that in other APIs I publish a event to this topic. And what I do with that is, just like with any other minimal API endpoint, it's just a normal endpoint, but the magic happens when I use with topic. So decorating it with topic to say, on this particular pub sub and this particular topic, you will receive a payload called order completed. All right, or you can listen for a payload of this type, and once I receive this payload, I'll go ahead and just deal with it like it's any other normal request. I can do with it whatever I need. So we can see another example here with topic on that pub sub cart topic. It's just slightly different topic. When items were added to the cart, I can get a different event type here, different payload, same sort of thing with topic on a particular pub sub and the topic I want to listen to. And I'll do that for a few other things here. So this is the magic for wiring up a message or event listener to a minimal endpoint using Dapr. Cool. Now, let's go and do something a bit more interesting. Let's go and fire up this whole thing. So I've got one of the old school ways of doing it. I just got a command file. I'll run that. It's going to go and start off a bunch of APIs for me. Well, actually, it starts the sidecars for me, and then it starts the APIs for me on top of that. Okay, so you can see I've got a number of them being spun up here. And what we normally see is a whole lot of logs from Dapr, and then as well as the logs being published by our .NET application. So the normal .NET run output also shows up in here. And so you can see here, for instance, our gateway API is listening on port 7192. If I go to that, okay, of course, there's nothing there right now, but if I go to the right endpoint, so /API, here I have the Swagger UI that shows me all the available actions on or endpoints on my services. Okay, so for this user, I'm going to just make sure and see that my user actually exists. Make sure everything is in working order. Great. So I execute that, and I get back the information about my user. I'll just make sure we're zoomed in. I get all back this information. The email comes from my work email, which is great. And so my user exists. Great, that's what I want. Now I'm going to do a few other things. But then let's look at my cart. So I want to go and get my cart. So type in my username again. And I can see here that my cart is empty. There are no items in there. So let's go and add some items. So try it out. Now, I just happen to know what to do here. So put in my username. I know that there's a product ID of 1, and I want one of those. Execute that. If all goes well, I get a 200. Great. So now I'm going to go back one step. Let's just see what's in my cart. Go back, and here we go. So I've got one of the product ID and product name says that it's some bread. Cool. And the price is 5. Let's add something else. So let's go and add product ID 2, and let's add 2 of those. Execute. So 200 again. Great. And if I then go and inspect what's in my cart, now I see I've got a piece of bread and I've got 2 pieces of cheese. Excellent. I'm happy. Okay. Now what I can do now is actually I can debug all of this, right? So how do we debug our microservices running on Dapr? So if we go back to Visual Studio, there's no easy way here to just start and debug our microservices directly from within Visual Studio. And what I did was I actually started the microservices using a command file. And so there's multiple ways you can do this. I use the command file. It's quite straightforward. You can use Docker Compose, or even if you're on Mac or a Linux, the Dapr CLI has a way to specify how to run multiple files or multiple apps at the same time. But it doesn't quite work on Windows yet. Hopefully one day we'll have that. But I just went for the straightforward command file in this case. So we're using the Dapr run CLI command. For each app, we have to provide an app ID. So I gave them all fairly useful names. They all have to have their individual ports. I then go and enable SSL. And for each application, I also have to say, look in this particular path for your components. Now, these are the components I want to use. And the Dapr CLI will go in and load all of them for me all at once and start up the application. Then after the Dapr CLI has started, with this after the sort of dash command here, I then want to give it a second command. So I just want to say .NET run. And I'm being quite verbose here. I want to make sure I use the right launch profiles for an exact project, a CS project file. So I go and launch all of my microservices one after the other using this command file. Okay, and so fairly straightforward. Now the Docker Compose is also a really nice thing, the first class thing in Visual Studio, and you should be able to go and debug your applications from within Visual Studio. But that's actually a lot more work than this command file that I set up here. Now, what we can do though, because the microservices are running, if we go into Visual Studio and we want to go to attach to processes, so Control P is a shortcut, we go here and we see a whole bunch of stuff, but I know if I just type in Dapr shot, this is the prefix I use for all of my APIs. I can select all of them and then click attach. We give that a moment and we can see some magic is happening. Should be able to see the outputs. Here we go. Now, if I go to my, let's go to the cart service, okay? And if I go to the submit, so if I want to put a breakpoint here, good. See, it's red, solid red, kind of means it's going to work. Fingers crossed. Then the next one is I can actually go and then break on my orders API. Let's see, what have we got here? So here are my orders endpoints. So I know this one's going to receive a message for when someone submits or checks out their cart. So we're going to come here and look at this particular order and see what the application then does with it. Okay, so I've set some breakpoints. I go back to my UI here. I then want to go and say submit this cart. So I'm going to give it my name here, and if I click execute, it should break straight away into Visual Studio. And now I can see here, hey, this is the username that was passed in. I can now step through my code with all the stuff that we're used to. I can get a cart for William. See, let's inspect that. And yeah, there's a couple of things in there. It all looks great. Exactly what I want. Okay, so I can step through. I can create a new order object. I can then go and I'm going to just go F5, publish this event. Very quickly, you can see I came into a different service now, which is the orders API, and I have received this full order object on here, especially because I was listening to this pub sub on this topic. Okay, so we have our order object here. All right, just do this here. Might be a bit easier. All right, so you can see here all the items I wanted. They're all in there. Quantity 1 and 2, product 1 and 2. Awesome. So it's all there. Everything I want, I can debug and step through, make sure the process that I want to work with is all good. I just went a little bit too deep, but it's all right. Press F5 and I can get back and say here, oh, cool, I submitted an order. Now what I want to see is on my orders API, I can see some output here. So it's progressing an order from order received to processing, and now it's completed. And what happens after it's being completed? My notifications API actually receives the order completed. This is the one I want to use later on for sending emails, right? So it will get the sort of order completed message and go and do some extra work for us. So if I then go back to orders endpoint, and then show here process. Oop, don't do that. Process order. You can see all the sort of fake process and background work that I simulated. Publishing the event at the end saying that the order is completed. My notifications endpoint will receive this message up here, and yeah, we should have broken here, but yeah, I get that order complete, and from here I can go and take that and send some emails, which is pretty cool. Very, very cool. Now, all that's happening here is I'm talking to really basic interfaces, basic concepts, and everything seems to just work beautifully. Okay, and the magic is that if I close those things down, we don't need those. What I want to show you is these components. Okay, so very straightforward configuration for setting up a pub sub and a state store in this case. And when we publish this to the cloud or somewhere else, then this configuration changes, but nothing inside of my application will change. There's nothing about specific components or anything being loaded or used in here. All that we care about are the names, the names of the stores or the pub subs, and the queues and topics, and app IDs if we want to do some service-to-service invocation stuff. And that is it. It's really straightforward. All right. So we saw what the components look like, how you configure them. And when an application starts up, it knows to talk to the sidecar. And whenever we call those APIs, the sidecar takes care of everything. It's got this spec. It knows how to connect to those services, and it does the hard work for us. Now, resiliency is, if I configured it properly, it could have shown you there how to use timeouts, retries, and circuit breakers, and even the health checks. So it's just something we have to do to keep our services running, especially transient faults. We don't want to have to go and turn our services off and back on because something else broke. We want to just to try again, and ultimately we might want to give up if there's some real tragic failure, or we can use circuit breakers, which is kind of a really nice way to halt operations for a while, not hammer the downstream service that's struggling, and eventually, we just sort of probe it and say, hey, are you back up and running? If you are, great. I'll close the circuit and keep running. Otherwise, I'll stay open. Now, you can actually go and look at the documentation for resiliency, and there is quite a lot. This is one of I think this is probably one of the biggest parts of Dapr in terms of the configuration. All right, so there's a YAML spec here that you can use to go and I'll just make that a little bit bigger, to define different policies for timeouts, retries, and circuit breakers. There's quite a lot of configuration you have to do. Now, if has anyone ever used Poly before? Yeah, all right. Now you don't have to use Poly anymore. Now you just have configuration. You don't have to write the code. You just configure your resiliency. That's awesome. All right. Now, this only applies to the stuff that you're running with Dapr Sidecars, right? If your application still needs to talk to some other external API that's not in your network and running a sidecar, then of course you have to deal with the resiliency there. All right, this is not going to solve that problem for you, but you can do it for all sorts of stuff. The individual components, you can target individual applications, or you can have just general defaults as well. And there's quite a lot to play with, right? If you go through and look at all this stuff, yeah, you'll be amazed. But it's pretty cool, okay? All right. So resiliency is one of the big problems that we don't have to solve with our own code anymore. Dapr brings that for us. It's really cool. And if you want to sort of put it in a picture, you can have an application on the one side with a Dapr Sidecar running. We give it a resiliency spec, and if anything goes wrong between the sort of service to service example on the top, Dapr will take care of the timeouts or the retries. These two things. If one sidecar can't talk to the other sidecar, it'll try its best to stay alive or eventually give up. Same with, we can have a spec that instead of service to service, it can be service to component. All right. So if we're trying to talk to our database or a state store, it'll do its best to try and get the message out to it. And the sidecar does that. Our application doesn't do it. For instance, in this one, we want to, in our application, we want to do save state. That message goes to the sidecar. My application's ready to go and do other stuff now. The sidecar will try and make sure that it actually goes and saves that in Redis. It's pretty cool. All right. Now, if you put it in a bigger picture, you look at all the different interactions, the different building blocks you can have in Dapr, the resiliency can be done everywhere. So this is what I said earlier. It's probably one of the biggest parts of Dapr. You'll definitely be there doing this for a while, but it's fairly straightforward. You just have to pick where you want to do it. Now, you don't have to do it for all of these individually. You can set some defaults that apply for everything. So you can keep it simple. Now, bindings. This one is quite interesting. And I thought the whole point of all the Dapr building blocks is to abstract things away. But now when there's a binding that's specifically for something like blob storage or SendGrid or one of the other ones, I thought, that doesn't give me quite a lot. I'm still talking to SendGrid directly in some way. And when I actually started using this, I realized it still reduces the complexity of my application, because all I do is I call the sidecar with an operation and a payload. My application doesn't have an actual dependency on SendGrid, for instance. That lives in the sidecar. So if someday I need to reconfigure SendGrid or change something on it, I just do it in the sidecar or the component configuration. I don't have to change anything in my actual application. All right. And we're actually going to build something with SendGrid later, so I'll show you how that works. And like I said, it removes the dependencies from our application. You won't find the blob storage or the SendGrid NuGet package in your application. Cool. Now, this is where we go and get a little bit deeper with the code. But how do you actually get started? All right, so I gave you a little supercharged version there before, but if you went home and started yourself, what do you have to do? First, you have to install the CLI. So you go and use winget, because you're in a Windows box. That works very well. It's quite nice. But otherwise, you can use, I think it comes from Brew, or just go and directly call one of their scripts. They've got a lot of examples on the Getting Started page. Once you have the CLI installed, you just call Dapr init, and that will go and download some containers onto your machine. So you need Docker Desktop. We won't be, definitely need containers for microservices now. It just makes things work. So that'll get Dapr onto your machine, and then you can get started. Now you'll need a project, so we'll create a new .NET new Web API microservice project, and add a couple of packages. That's the minimum we need. And then we can start running it with the Dapr CLI. So Dapr run. And then you can give it all those custom arguments. Okay. So development and debugging is actually a bit annoying on Windows. It's not been foolproof yet. Definitely better on the other platforms. And if you use VS Code, it is really convenient. It does just take a little bit of work to set it up, but it's good. And Docker Compose will work very well on Windows, especially with Visual Studio. You have to set up a service for your application and each of the sidecars for each of the applications. So it's also, again, a bit of work to get it set up, but that'll be a sort of first-class thing to run and debug in Visual Studio. Or you can try another project called Dapr Sidecar. This will start things in a different way, where we saw Dapr CLI to run and then run our application. This goes the other way. Our application starts up and then it starts the Dapr Sidecar, right? It's a different way of doing things, but it's quite nice. Just, again, on Windows, it's not been the best. It still has issues with discovering some of the port numbers for me, but you might have a bit of better luck than me. And as we saw with some of the building blocks, service to service, there's a create invoke HTTP client. We'll use that a bit more later. We've got publishing events, and to receive events, we've got with topic, get state, save state, and query state. So query state sort of just running a very simple filter to read through a bunch of state items and give back just what you need. So with this sort of application that I've built, here is a nice sort of basic UML type diagram. And the interaction of our users would be, they go to the API gateway, they call the post endpoint for adding an item to the cart, goes to the cart service. The cart service then goes, hey, before I add this thing that William wants, I'm going to make sure William's an actual customer. So we'll validate William from the user service. And if everything's good, great. Then we'll go and validate this product that we want to add. Does this product actually exist? And if you want to make things more complicated, is there stock, all that kind of things. Now, once all the validation is done, we can go and add this item into our cart. So we save that cart into our state store. And then at the end, we publish a message to the bus to say, William submitted his order, or he is trying to check out his cart. And then we can receive that event into the order service. And when the order service gets it, we can start processing the order and eventually ship it off to the user. Okay. Now, what we want to do is we're going to extend this application that we have and add another service. You can never have too many microservices, right? Okay. So with that order completed event that we receive into the order service, right, we also receive it. The order service, once it's finished processing the order, it'll publish another message saying order completed, and then our notification service will receive that. Then we'll have to get the details of the users and the product, generate an email, and send the email out using one of the SendGrid bindings. All right, sounds simple? All right. So I'll go to my Visual Studio. All right. So with my notification service that I have here, just a basic .NET app again. It's not much to it. It's quite short, only 4 to 5 lines long. Where I add Dapr client, I'm going to have to add my email service. I've got app insights again, and I have mapped some endpoints here. And currently this endpoint will receive an order and just spit it out to the console, right? There's not much to it at all. I want to show you how we want to add SendGrid to it. But just for the sake of saving a bit of time, here's one I cooked up earlier. All right. I'll step you through what I did. So I still receive the event, but now I'm injecting my email service as well as the Dapr client. Okay. So the logic here is I receive the order, but I can't go and just directly query the state of another microservice. And why is that? So this is the cart service. I can't go and get state directly from the order service or the user service, all right? And you'll see the way this works, the items that are stored, that big enough, hopefully we can, there we go. So the way these things are stored is that each key or each ID is prefixed with the API, the app ID, okay? And we can't fiddle with this. The Dapr Sidecar knows the app ID that it has, and it will automatically attach this to the key when it tries to query this. So if I query in my application that state store, even though it's all the same Cosmos DB, the order ID of 1, I can't do that because automatically I'm in the cart, right? Hang on, am I in the cart one? Which one's this one? Notifications, sorry. So because I'm in the notifications one, there's not going to be any notifications pipe 1 key at all. So I can't get the state from products. How do I do that? Well, now I have to do a service-to-service invocation. And this is where I use just a little shortcut feature in the Dapr SDK to create a HTTP client and direct it towards the orders API. Now, that's typically all you need. But for some reason, they've decided, and I'll show you why, they hard code this to just HTTP. All right. I like to use HTTPS. All right. So I have to go and override that and just manually form that myself. But I still get the headers and a couple of bits that they add in there. All right. Now, you can make this work in your own way, but that's just what I did for this demo. So I'm definitely just calling HTTPS orders API. Under the covers, it'll be localhost port 7000 something. Doesn't matter. I don't care anymore because Dapr does all this for me. And I can ship this code as is to Azure and it'll work. No config needed. So I'm just doing a normal, and this is the standard HTTP client. Now everything that we're familiar with, we just use that. All right. So get from JSON, and I've just got the route there for query parameter to get the order and the username. Just a bit of basic defensive checking. Then I generate the body of the email, create a little email object, and then I send the email and say, okay, it's all good. But how did I actually send that email? And if you look in my application, my project file again, there's no send grid in here. Right, there's no send grid NuGets at all. But I'm using send grid to send this email. So I'm just crafting up a dictionary of fields. And more importantly, I probably should show you the spec for the send grid binding. And also a link I should have clicked earlier. So you can actually go and look at all the bindings that are available and the spec for them. And then here is how you describe that component. So you can have some default values that you don't have to provide from your application or from here, but as long as you get the API key in there because it's required. So you don't need this in your application. So you can see here the bindings of type twilio.sendgrid. Cool. So in my application, I just go and make sure I fill in the fields that are relevant for this email. If I have a CC or a BCC, I add them in, and then I call this invoke binding async. I'm using the binding name, which is the name of my component here, SendGrid. Not very creative, but you can call it whatever you want. Then I have to give it an operation name. So in this case, there's only one called create, and I have that here. So to SendGrid, create, and then the email data that I need. So here's the body, and here's the metadata. And it'll send it off to the sidecar, and the sidecar will connect to SendGrid, and off goes the email. Now, let's test this. Actually, I'll skip the step. I'll test it in Azure. We'll make sure everything is running there. Okay? So very straightforward. I can actually use bindings by invoke binding. Straightforward. So just one of the other building blocks. Next up, we can go and combine all this Dapr stuff with Azure Container Apps. And like I said, they're good friends. They really like each other. Dapr is just one of the nicest things to use in there too. So we've got our application. You saw this before. And running it locally, it's all the .NET APIs. And I used a mix of Redis and Cosmos locally. But when I ship this into Azure, now I'm running on ACA, and I've swapped out Redis for Cosmos DB, and also swapped out Redis for Service Bus to do the pub sub. Cool. I didn't have to recompile or do anything else to my application. It's literally just the YAML spec that changes. And so all we have to do is we commit the code from our machine to GitHub. It will run a build there, build a container, send it to Azure Container Registry, and then that'll deploy to our Azure Container Apps environment. So how do we do that? So now, I've already got it deployed, and I can go to my notifications API, which is here, and say, I just want to rerun this and make sure that I run the right branch, which is this one will update the application to say, hey, you actually should be able to send emails. We'll check that. I'm in the right branch. Yep. So that's all this code was committed, and I did plan everything correctly. And this is just stuff that I did earlier. Okay, don't need that. Cool. So chances of success should be high. So I'm just deploying this out to Azure. And so what we can do is, this is the right one. Yep. And I can go back to here and look at the notifications API. And shortly, we might see a second revision of the app showing up here once GitHub gets to publish it for us. Now, what I have is a whole lot of Bicep. So this is the infrastructure as code first-class citizen for Azure. It's an extension of the old ARM template, much nicer. So I have a main template here that sort of just spins up all the core infrastructure that I need. So my container app environment just here, and log analytics, app insights, Cosmos DB, Key Vault, service bus. Okay, and I also then have to set up my Dapr components. Now earlier I showed you that I'm using a bunch of YAML files to do this, right? Now you can reuse these YAML files with small tweak. You can publish them directly using the Azure CLI for container apps. But if you're using Bicep, you have to do things a bit differently. But everything that you do here is exactly the same as you did in the YAML file. It's just you have a little bit more Bicep code around it. So let's say I pick this state store one. You can see here, I've got a secret that I'm referencing. I don't want to put the secret directly in the YAML spec, but the same URL, master key, database, the collection, those are all the same fields that we find in my state store here. So the URL, master key, database, collection. Okay, so it's the same settings, it's just in a slightly different flavor. And what we can also then do is to add scopes and say this component is only available to these particular application IDs. So if I don't want a certain application to have access to a state store or a pub sub or key store, I can just deny them access. It's fine, right? So it's quite straightforward. So there's a fair bit of Bicep to look at. There's also the one for each of the individual container apps. That there's really not much to it, apart from I was currently saying the scale, give it access to the container registry to pull the images, and that I was saying here, most importantly, that Dapr is enabled on port 80, and that this container app, its app ID, or for Dapr, is, in this case, the cart API. Same with all the other ones. They all have exactly the same app ID. All right? And then what we do here, so this is the gateway. So I want to actually enable ingress for this gateway. So I can actually call it from a public endpoint. Whereas if I look at, say, my email service, that's false. I don't want you guys to call this and spam my email sending thing without any sort of validation or anything, right? So in the networking sense, the only application that's exposed publicly is the gateway. Everything else is a private service. So you can't hit those endpoints directly, okay? And then to keep things simple, from GitHub, I've just got a very straightforward, it's at the bottom, pipe workflow file, if it just wants to go all the way to the left. So just on push or pull request on the right thing. So I don't want to ship everything all at once all the time. Only if there's a pull request on a thing that changed, build and deploy just that thing. Don't ship everything all at once every single time. And just a bit of basic stuff for getting the app built. But you haven't seen me use a Docker file yet, right? Cool. So with .NET now, you can actually directly build your application into a container using the .NET build, .NET publish CLI. And all you do is to make sure you say use the default container profile, and then tell it which container registry to go to. So you give it the tag, and you also give it the server name, and there you go. Now, as long as you've got like a AZ ATR login or Docker login. You've authenticated, then you can push to that container. So that's just one line to build a container and send it off to the registry. Then to deploy, to log into Azure, there's obviously various ways of doing it. And then all I do is just to run the CLI. So keep it simple. I don't want to split up and have new bicep files that redeploy the application. I thought I'll keep it simple, use the CLI. So AZ container app update. So I don't want to create a new one. Just want to update the one that's already there. Give it the name for the container app. Tell it which resource group it's in, and the name of the container. And then very importantly, so I use this GitHub SHA, right? The commit hash for this workflow. So it picks the right image. And that's it. It just goes and we probably waited too long. We've seen the where's the Azure window gone? This one. I think we might have missed the second revision showing up. Oh well. I wonder if I can show you that in another way. So this is the one 6 minutes ago. Gee, you've been talking a while. All right. So it should be deployed. Now, if you go and use the gateway application, right? So what I'll show you is my user. If I make sure that I actually have the right email address in here. Okay. So good. That should come to my work email. Great. And I'm going to make sure I have something in my cart. Empty. Okay. Now I have to make sure there's some products in there. So what do I do? So I want to add something in there. Now I just happen to know what to do here, right? So give it my username. I want a product ID of 1, and I just want one of these. All right, good. Sending, and something went down. That's awesome. Why would something go down? So now we need to go and debug. So which one? Sorry? Oh, that'll be why. Sorry, I wasn't paying attention. How did I get that wrong? I can't spell my own name. All right. All right, let's try again. Hey, that's better. All right. Sure, this is working as well. So, all right, I want to now check what's in my cart. Cool, got one piece of bread. All right, let's see what happens if I add something else. So I want to add 2. I want to add 2 of whatever 2 is and say execute. All right. Now I have a piece of bread and 2 pieces of cheese. Okay, I'm happy. Now I want to go and submit. I want to actually check out. All right, cool. So I want to say William to check out his cart. Before I do that, let me just get this orders API. I'm going to refresh that. And I might just collapse that a little bit. Okay, so you can see the logs here. So now, as soon as I submit this order, fingers crossed, well, here we go. We received an order. It is saving it. So it's progressing the order from new order to order received. So, now it's processing. And I want to actually get to my notifications one here. Refresh this. Make sure this shows a bit of logs. Okay, cool. Because as soon as this one goes to order completed, which it just did, well, here, received an order, sending an email to William at SSW. All right, now let's see what happens. Will this open on the right screen as well? That's always the big mystery. All right, so it's gone to my, new Outlook is very different. Now, I know it goes to my junk mail, but here it is. Great. Here's my piece of bread and my piece of cheese. I actually forgot to count up the number of pieces of cheese, so this is slightly wrong. There's a small bug, but cool. At least I have some bread and some cheese, and I have it in the email to prove it. Cool, that worked. Nice. So does anyone else want to try and run this and see if we can generate some traffic? Go add a item to the cart and push it through. I'll give you some time and we'll come back and look at this a bit later. All right, so now you saw I can build the .NET application, from GitHub. The container goes and gets pushed into ACR or Azure Container Registry, or you can choose Docker Hub wherever you want, doesn't matter. And then eventually you're running in Azure Container Apps. Awesome. So that was a live demo. Now, in summary, the cons, right? The stuff you have to be well aware of. The local dev experience on Windows definitely needs a bit of work. It is better than it used to be. Definitely try the other platforms. If you want WSL, if you want to go on Linux or Mac, they actually work quite well. There's actually some features on there that aren't available on Windows yet, especially for running up multiple apps. Now, when we're using these sort of components, sometimes you might feel that you've lost the ability to fully harness one of those services. You're not wrong, but then you can make a conscious decision to go and utilize it fully. You don't need Dapr in every scenario, okay? If you realize there's something unique about SQL Server or Cosmos DB that you need to serve your applications, go for it. This shouldn't hold you back, all right? The building blocks are generally awesome solutions, but there will be cases where it won't work, okay? Unfortunately, some of the components available on Dapr are currently still in alpha stage. So they might break, or they might go away, or might never go any further than alpha. So just keep an eye on the status of these components. There's like 120 of them there. The major ones that are stable, the ones that we commonly would use, they're great to use, okay? The pros, all the good stuff. So developing these with these building blocks makes dev work easy. We've reduced the complexity. We can focus just on our application most of the time. The logic inside our application. We're not dealing with the complexities of setting up and wiring up something like Service Bus or RabbitMQ into our applications. We don't have to worry about how our application talks to Cosmos DB or Redis. That stuff is gone. And so that just reduces the complexity immensely. The dependencies goes hand in hand. Less NuGets, less code, less headaches. I do really like this. It's serves me quite well. And a lot of the sort of cross-cutting concerns, like resiliency stuff, there's other things when it comes to the security in terms of adding OAuth to endpoints. It's configuration. It's not stuff that's in my application anymore. It's really nice. And again, lots and lots of choices. Now, the cool thing is, I can just swap out infrastructure as I like. My application doesn't care. It just keeps running. So microservices, all these things that we have to think of, super painful, but with ACA and Dapr, it's less painful. So, if you want all of that code, all of the things that you saw, go to my GitHub repo there, and even the presentation, all the slides, I'll put it all up there for you. And go and have some fun, write some awesome microservices, and show off what you've done. Thank you very much. Is PHP the best dev language? I don't know. I want to answer that question. PHP. Who are these people? Okay, cool. Matt Wicks is here. Oh, Matt Wicks. Oh, yeah. I better go and have a look and see what he's done. We can go and query the state store and see. Why not use Project Ty to start up all the services instead of a batch file? That's a great question. I used to do that, but Project Ty is no more, really. It's unmaintained. It's unfortunately not going to be going forward anymore. There is an issue in the GitHub that explains that. If you read a bit wider, then they do want to focus on something like that to start up multiple services and so on. But right now, the focus is to use Docker Compose in Visual Studio, right? The other option is VS Code, the Dapr plugin there. That's great. Just a bit of setup work and configuration you have to do to make it do what you want, but it works. It works quite well, especially not on Windows. Yes, Chris Clement, would be nice if we can press F5 to run all the services from Visual Studio. Yes, Docker Compose is your friend. Give that one a go. Yeah, it looks like it's straightforward enough to set up Rider to start up the Dapr service. Yes. So if you've used Rider, I forget exactly what it's called, but there's some launch profiles or something in Rider that you can use to start all the stuff up again. It's just going to be a little bit of legwork to get started, but you probably won't be adding 20 microservices at a time. So if you have to do it one at a time, it won't be too bad. So cool. Any questions from my Melbourne audience? Ward? Yes. Okay, so I'll rephrase the question. So I used SendGrid to send my emails as a binding. But if I go look at the list of bindings, I don't just show you the full list. There's a long list of bindings that you can use. Actually, is it in this? It's actually a bit further down here. So let's go here, component specs, and then bindings. So here is where you can see the name of the binding and the status of it as well. So you can see what's in alpha. So there's GraphQL. There's not one specifically for MS Graph, not out of the box. But what you can do, I think there's a link here somewhere. You can go to the components contribution repo, and you can write one and share it with everybody else. It's an open source project, right? Like all of this, the Kubernetes, Envoy, Dapr, they're all open source. If you want something that's not there, you can go and contribute. Yeah. Here's SendGrid, Redis, Alibaba stuff, AWS, Cloudflare. You can use Cloudflare queues. Great. I haven't used them, but they're there. All GCP, all the Azure stuff, and ZB, Camunda Cloud. Cool. I don't know what that is, but it sounds cool. Cool. Any other questions? Yes, sir. Can you write functional tests on the sidecars to make sure the sidecar... Okay. Honestly, I haven't written a binding or any of the plugins for Dapr myself. I haven't even seen the SDK. I know it's there. There's a big repo that you can go and actually look at, right? So here's the GitHub link straight to Dapr. And if we look at the repos there, I'm sure... so here's the components contribution one. There's one for each of the SDKs. Now, if you go and have a look, tests. Hey, all right, there's something there. Yeah, end to end. You can definitely have a dig here and see if it suits what you want. It sounds like it does. I would be surprised if it didn't. Yeah, it'd be kind of weird if it didn't, right? Cool. All right. Any other questions? Another one, Ward? The question is, if I have my container app, which I was using before, running in Azure, waiting, not doing much, will I get billed? Yes and no. No is if you've gone at scale down to 0. So it's not running. If it's inactive, there's a reduced rate for the CPU and memory charge, right? I think it's like a third of the full price. I can't exactly remember. But when it's inactive, it's a much reduced bill. And then when it's active, you get charged for the gigabyte seconds, I think, whenever the CPU and memory charge per second. Okay, so scale it down to 0. Just so you're aware, with the Dapr stuff, if you're using the standard CPU memory metrics, you scale your app down to 0, and you call them, they won't wake up. There's no metric to spin your application back up there with that. If you use Kida to message to monitor a queue length or something else, then you can spin up from 0. Okay, so just be aware. It's just a small quirk there, but it makes total sense once you start working with it. Okay, so Kida is when you add some scaling rules in there to monitor. I might as well show you here. So the Kubernetes event-driven auto scaling. If you look at the scalers that are available, here's all the things you can look at and in some way decide, scale my application out X units. All right, so you can look at blob storage or event hub or service bus, whatever, more YAML. And then from here you can see after so many messages or something, and decide how much to scale out. All right. Would it be like Azure function? It's still consumption based, yes. So it's a per second charge. So the Azure Functions pricing and Azure Container Apps pricing are different. I think they're different products, obviously. Off the top of my head, I don't have the numbers, but those are the pages you'll be looking at. Do a good comparison. It'd be good to have some feedback, which one you think works for you. So someone's got a question online. Is there a way to check the Dapr Sidecar running before calling? Good question. Yes, there is. In the Resiliency configuration, there's some initialization timeouts and a couple of other policies that you can check there to make sure if the sidecar is running. You can also have health checks on the sidecars as well. So if anything's monitoring the sidecar, it'll be able to tell you whether the sidecar is healthy or not. Okay, so yes, all that health checking, it is in there. And if you check out the Resiliency page, it actually describes it in there, or at least one of the links off there describes how to do that. Good question, thank you. All right, any more questions? We all good? Oh yeah, one more. So when I'm running all the sidecars on my local machine, does it run all the sidecars locally as well? Yes, 100% it does. Yes. Okay, so the question is in two parts. When I'm running the sidecars locally, also running the APIs locally, do the sidecars run locally? Yes, they do. So this Dapr run, this starts the sidecar, all right, and it gives the sidecar this app ID, okay? And it runs on a particular port, and then I tell it which components to use, okay, on my local machine. And then I say .NET run for that particular project. So that components is a folder. So Dapr goes in, great question, no one has asked this yet. That folder contains all the YAML files. So Dapr would look in that folder and load all of the components. So Dapr doesn't run Bicep directly. Yeah, so going back to the Bicep stuff that I had earlier, that is deployed to Azure Container Apps. Yeah, so then it takes that definition and it starts the component for you in the container app environment, and then your container application spins up and it connects to the sidecar that's available for it. So that's where those app IDs come in handy. You can, so I mentioned earlier that you can reuse those YAML templates from your local machine, but not as Bicep. As you can upload them via the Azure CLI for you. Now there's a command. Yeah, I'll have to dig it, but it's something like AZ container app Dapr something update. There is a fairly long command, but you can actually upload the YAML from your local to Azure. But remember, it's not going to talk to a service on your local machine. Okay, yeah, it's going to need something in Azure that it has access to. Cool. All right, I think that's all for questions. Thank you very much for everybody here in Melbourne and online. It was great. So see you all next month. This is William from SSW signing off.